All right. So we're continuing on with 3A.1. And when we're talking about what's happening here, we're going to tie this into a horizontal translation because essentially that's what you're doing, right? You have a fixed pattern that's taking place, and you're just translating that specific pattern some units to the right and some units to the left. Does that make sense? And so if you go back and look at example four, we knew that our period was five, meaning that we could translate it any way that we wanted to, 5 units to the left or 5 units to the right. And so the equation of our transformation would be x minus 5. We're taking whatever that function piece and where we're starting at, and we're moving it 5 units to the left. Oh, in this case, it'll be 5 units to the right because it's x minus 5. But 5 units to the right, and then shifting back and forth. So that's why when we were, all my work is gone. Vegetables. Um, when we were multiplying by we were adding on multiples of five. That's because how far we had to shift it to the right or how far we had to shift it to the left. Does that make sense? Even though you don't see my work, you should have it written down because we wrote it down. So, keeping that in mind and what's happening, if I am here and trying to figure out all the patterns and where things are taking place, I'm asking for the where would hold on, sorry, I gotta sneeze. Oh my God. Here's the suck. What would be the rule or pattern that I would get to find out every time I would get a one as my output? Oh, thank you. So keep me in mind and thinking of this as translations. Where would that happen? All right. So the first thing is to establish our period. And how long is it? 4 units. Then it says your output is one. So where does that output of one begin? Well, our first output of one starts at right here. Does that make sense? At x equals 2, the output is 1. The next one happens 4 units later. And then that pattern would continue every 4 units. Mathematically, when you say every, what does that mean? Every? Mathematically? Means what? Every operation. What operation is every mathematically? Every one of y'all are getting $5. How would I calculate that? Multiplication. So the word every means multiply. We're multiplying. Yeah, that's crazy that to bring back money. So if I'm starting at 2, right? And every 4 units, I keep going. That's where my results are going to be. And K is an integer of how many times I am repeating that phase, that period. Does that make sense? So graphically, I can see that f of 2 equals 1, and I can see that f of 4 equals f of 6, not 4. F of 6 equals 1, and then it's going to continue. But it wants to know how would I find all of the inputs? Well, all of the inputs would come from that rule. Does that make sense? Remember I said you were overthinking it? I meant that. All right. The next one, the next example that we're leading into is a play on of a guaranteed FRQ. So for your AP test, you are going to have an FRQ that is based on finding patterns, a sinusoidal pattern. And we're going to start by thinking of that as a periodic function because it is a periodic function. But we're going to start off without talking about sine and cosine, and we're just going to look at it just from where we are. What we do know, what we can calculate. So looking at this example, we have this clock here, and the clock shows that I'm going to read from here because I can't see from that side. The figure shows a large clock mounted to a vertical wall. The clock has an 8-inch long moving minute hand. The center of the clock is 120 inches directly above the floor. Um, at time t equals 0, and the minute hand is pointed directly up at 12. However, the clock is not working properly. Oh, thank you. And the minute hand is moving twice as fast as it should. Thus, the next time the minute hand points directly up at 12, it is at t equals 30. As the minute hand moves, the distance between the endpoint of the minute hand and the floor periodically decreases and increases. Oh my God. Okay. I need to. I haven't done that yet. All right, so let's put in what we know. Now, from the center to the floor, it's how far? 120. This is like the old school clocks that used to be in the hallway and at some hospitals before they all became analog clocks. What did I write? You see nothing. Yeah, it says inches. Okay. And then we know that, what else do we know? Is someone let Miss Katani in? It's going super fast. And then how long is the long hand? 8 inches. So this is 8 inches. So at the height of it, what is the tallest it could be? Oh, Miss Katani? I'm dying.
This is for you.
Oh,
Stay
you.
alive.
Oh, you're sweet.
Have a good day.
Thanks. I'm trying to. Someone likes me. All right. At 128. So at my highest point, I know that these values have to equal 128. Does that make sense? Okay. Now we're going to talk about at our lowest point. At our lowest point, what would it have to be? Our lowest would just be 120 because it would be here at the center, and the center to the ground is what? 120. So we know that our lowest points have to be, that's not a 20. I don't know what I just wrote. I wrote all the numbers. Are you still with me? So do we see how we filled? Huh? Okay. Let's talk about why it's 120. So it says that from the center to the ground is 120 inches. So if this clock hand is going to move around, it'll be at 6, right? And that 8 inches is going to be part of this 120. So the shortest it can be is 120. Does that make sense? I still see some confusion.
They said the lowest point was 112.
No. Wait, we gotta subtract.
That's what I thought.
I didn't subtract. 120 is not the lowest. It's your middle. I knew that. Making sure you knew that. I just announced that I'm dying. Because the show must go on. The show must go on. Huh? That isn't 20. It's a 0. Okay. Because I feel like we don't have any full weeks and everything is off. And if I took a sick day, then I feel like we'll be even more off. And I'm just gonna be here suffering. And I can't take too much meds because everything makes me drowsy. So it's gonna suffer even harder. I don't think we should, but nice try. Because that's not how any of that works. All right, so now we've established all of our outputs, yes? Correctly. Yes. All right. Now we're going to talk about the inputs. The inputs are going to be the easy part. So at 128, I'm here at 12, and it said to treat 12 as our what? Our zero, right? So it says to treat the noon as our zero starting point at time zero. So we know that this is zero. Does that make sense? 0 minutes is 12. Now time is on cracked. So even though this is normally this would be 15 minutes, right? But it's not 15, it's half of 15 because it's doubled in time. Does that make sense? So this is actually 7.5. Agreed? Okay. And again, this would normally be 30, but we're actually what? 15. This would normally be 45, but we're at what's half of 45? You have $45. Each person is getting what? $22.50. So it's 22.5. Agreed? Okay. And then we come back around and it didn't take us an hour, it took us only 30 minutes. So those would be our points on our curve. Do you see how we establish those points? Once you establish the points, that is part one of getting the points for this FRQ, is determining the points. Okay. There are multiple answers as we learn more. And so you will get points for your multiple answers. But you get part one is just being able to say, what is your F, G, J, K, and P? And that's it. Was that terrible to establish? Okay. Now, next part is going to be a multiple choice. On the multiple choice part, it's going to ask you to decide on whatever interval it gives you. So it says on the interval T1 and T2, and it establishes what T1 and T2 is. What is the function doing? So our established T1 and T2 is, I can't see. Let's look up here. From G to J. So from G to J, what is the function doing? This goes back to concavity. It is positive and decreasing. Why is it positive? Because I'm what? It is concaved up. So from G to J, we are concaved up, right? So we know that it's concave up, which is what makes it positive. So establishing what type of concavity I have is going to help me eliminate the choices. So I would eliminate C and D. Now we're going to describe what is it doing. The function is doing what? Decreasing, which is why it comes down to these two, and the answer is B. And then all you're doing is part two is explaining why you chose your answer. So in part two, we would say on the interval from T1 and T2, the graph H appears to be concaved up, and the rate of change of H is doing what? It's concaved up, which we established. So it's going doop, 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 doop. Our slopes are going from super steep, negative, 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 negative to zero. So the slopes are doing what? Increasing. If I'm going from negative to zero, I am increasing. Does that make sense? So my slopes are going from decrease, 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 decrease to zero. So therefore, I am increasing in my slope value because these are negative slopes. Remember, concavity is describing your slopes at any point. And each slope is negative, and then they level out at a point which makes it zero. Because at that point, this is a zero slope, right? So I went from a negative to zero. That means that I had to be increasing. Yes? Does that make sense? On this side, I'm going from positive, positive, positive up until zero. So this would be a concave down with a decrease. Does that make sense? Because your slopes are changing. When you're describing concavity, you're describing how is the slope changing. If I was to take a slope of every point, what is that slope doing? And that slope in this case would be increasing because it's going from negative to zero. Okay. So I don't have enough room to write in this little space. So I'm gonna write it in this space. Is that okay? So we have on the interval And the interval that we're going to use, you either can actually describe what the interval is from G to J, or you could just use T1 and T2. They will take either one. From T1 to T2, H of X is concaved up, and rate of change, I'm just going to write RLC, rate of change is increasing. Is increasing. Hey, this is going to be a guaranteed FRQ. It just gets a little more tricky, meaning we use sine and cosine as we learn more about sine and cosine. Okay. But it is a guaranteed FRQ every AP test. Okay. I do not anticipate you guys leaving 6 points on the table. From this problem, I'm hoping that we at least all get 3 points. Okay. Those 3 points are going to come from these two parts, hopefully. But I do anticipate you guys not messing up.